Hello everyone, welcome to another video on shell coding on ARM Assembly Linux 32-bit course presented on YouTube. So in this video we are going to talk about the data types that we will encounter in our normal ARM assembly program. So talking about the code we have used 2 videos back, there I have declared a string with something called .askeys, which is used to declare a string with a null byte at the end of the string. So how many of them are there that we can use in our program? There are totally 4 that we can just use in our program, whether it is a normal ARM program or a shellcode program. So those are .word, which is used to just store 32-bit of values, .byte, which is used to store 8-bit of values, and here .ascii and .askeys are used to just demonstrate or represent a string with a slight difference. With ASCII we can declare a string without a null byte, and with ASCIIs we can declare a string with a null byte. So let me just demonstrate usages where we can use these 4 data types. So I have just declared a variable 1 storing values with worded data type. So it is used to store 32 bits of values. So this entire value is of 32 bit. Next, I have declared a variable 2 storing a value with .byte. So by this we can just at least justify that this can only store values up to 8 bits. Then we have declared 2 variables 3 and 4 with the same string but different data types, .ascii and askeys. So with ASCII, what we are just telling the compiler or assembler that this string is without a null byte, and with ASCIIs it is with a null byte. So what does a null byte tells us? Where we can use the null byte. So null bytes are used to just mark the end of a string. So if a null byte is appended at the end of this string, the string will be just that length only. The length of the string will be limited to that only. But without the null byte, the string length cannot be justified. So this is the significance usage of a null byte. So let's debug our program where we can use all of these stuffs, and I will show you the difference between the ASCII and ASCIIs in our terminal in our debugger session. So let's debug. So for this video I have created the datatypes.s file where I have declared all the things which we have just discussed in the slides, declaring the variable with byte data type and word data type, and also I have just declared 2 variables with ASCII, the strings hello and word, and also in variable 5 and 6 with the declaration of strings hello word with ASCII's data type assembler directive. So what does the program actually do is just it gracefully exit by the exit syscall and nothing else. So for debugging we can use the GDB multi-arch where in another terminal we have to just use the QEMU ARM utility, link it with another shared library which we have stored in user ARM Linux GNU ABI HL, create a debugger server by tag G on port 1234 and execute the binary data types. So after pressing enter, we have created a debugger server which we can access via any kind of debugger. We are accessing via GDB multi-arch by specifying file data types and using target remote localhost 1234. By this we will get the debugger session access of the process executing in another terminal. So by looking at the entry point functions start, we will just actually see the instructions of the program which is doing nothing, just gracefully exiting. So looking up for debugging these things is of no use. What we want to debug is the allocation of data into the program of all these things, the difference between ASCII and ASCIIs too. So let me just see the variables which we have declared in our program. So it is variable 1, 2, 3, 4 and 5 and 6 which we have actually declared in our program. So by just looking 1 byte at variable 1, we will see 1, 2 which is equivalent what we have declared here, and just looking up the 2 hexadecimal bytes we can see 1, 2 and 2, 1 which is this, And by looking at the 4 hexadecimal bytes as the variable one, we can just see entirely what we have declared in our code, which is 1, 2, 2, 1, 3, 4 and 4, 3, separated by a comma. So next we will just see of the word directive or in the variable 2. By examining the hexadecimal giant or 32-bit values in variable 2, or sorry, not giant, word or 32 bits. So we will just see 1, 2, 3, 4, 5, 6, 7, 8 is declared in variable 2 here. Separated by a comma, we have declared again 32-bit value 87654321, which we can see via defining 2 hexadecimal word of variable 2. So you might get confused by the thing word and giant here in a debugger. So don't get confused. The giant is of 64-bit and word is of 32-bit in debugger. Next we are going to see about the variable 3 and 4, which we can see by examine the string at variable 3, which is hello world hello. So by this we can just easily see the mark of the usage of ASCIIs. So we have declared 2 strings hello and word with ASCII. So here what is it actually happening is there is no null byte. In both of these strings. Because of this, when I just examine the string at the variable 3, it is printing hello and word consecutively with hello 2, because these 2 strings don't have any kind of null byte, but this does have. So the string ends up here. So this is the usage of a null byte. Using a null byte, we can just declare an end of a string. And if we just examine the string at variable 4 or variable 5 actually, then we can see we are getting only hello, and after examining the string 6, we are getting word. So let me just demonstrate you the internals, how these things are actually working. So examining the almost what I can say 14 bytes or sorry 12 bytes hexadecimal bytes of variable 3. What we can see here is it is actually hello word hello in hexadecimal HELLO. After that we are not going to see any kind of null byte at this point because it is just using ASCII. Then we are seeing hexadecimal representation of word WORLD. So it is not representing any kind of null byte. But if I just examine the variable 5, which is using ASCII, then I can just easily see we will see a null byte in here, which we are not getting to see here. So this is the significance of using ASCII and ASCIIs. We can just mark end of a string declared in our data section. So this was all for this video. I have just demonstrated the usages of all the data types you can use in ARM assembly, using ASCII benefits and disadvantages, using ASCII's advantages and disadvantages. So this was all for this video. If you have any question related to this video, you can just simply ask in the comment section, drop some likes and subscribe. Download the slides used in this video from the description, from the link of the PDF given in the description below. From there you can follow me on my Twitter and GitHub handles, and you can follow too. That's all for this video. Meet you in the next one.